I'm sorry. We'll move quickly into, can you hear me now?
Yes, we can.
Yeah, I think we should be able to catch up with the time very quickly. I'm moving to the next presentation, which is offensive language identification in code, mixed social media posts and comments. And the presenters are Charangan Vasantharajan and Uthayasanker Thayasivam. Let me introduce very quickly both of them. First is Professor Uthayasanker Thayasivam. He's an experienced engineer currently lecturing at the Department of Computer Science. He's a senior lecturer there, University of Moratuwa, Sri Lanka. And Moratuwa, Sri Lanka, after completing his bachelor's degree in electronics and telecommunication engineering at the University of Moratuwa, he obtained his doctoral degree in semantic computing from the University of Georgia, USA, and his research interests are natural language processing, advanced machine learning, and advanced data science. He has extensive experience, industrial experience, from globally reputed information retrieval organization. He has worked for Google, Microsoft, Ask.com, and Glassdoor. These are some of the top tech companies. And he's also an active member of both the National Language Processing Center and the Data Science Engineering and Analytic Research Hub of the University of Moratuwa. So let us welcome Charangan Vasantharajan and Professor Uthayasanker Thayasivam. So who is going to start first? Please share your screen.
Yeah, I will start.
Thank you. And we'll be sending you a cue on the time, so please.
Can you see my screen?
Yes, we can. It's clear.
Yeah, okay. Can you hear me?
You could get started. Charangan, we can't see your screen now. Yeah,
No, is it okay?
hang on, it's coming.
Okay. Okay. Hello, I am Charangan Vasantharajan from the Department of Computer Science and Engineering, University of Moratuwa. I am fascinated about NLP and machine learning. Now I am going to present my work on offensive language identification in Tamil social media posts or comments, which are largely code mixed or written in non-native script. We approach this challenge with various transfer-learning based models to classify a given post or comments in Tamil into 6 categories. This presentation is organized as shown in the slide. So introduction, dataset description, motivation. After that, we talk about some methodology and experiment setup and results. So finally, we will conclude the session. So first of all, the introduction. Over the past decade, there has been a tremendous increase in user-generated content on social media platforms such as Twitter, YouTube, and Instagram. They provide a common space for discussion and interaction for users to connect with each other and express their opinions and also share their knowledge. So users may use offensive posts or comments which may be directed towards an individual or community, which is one of the common problems in social media platforms nowadays. So they act as a catalyst for leaving offensive content, which could have a harmful and detrimental effect on users' mental health. So, however, users in social media platforms use the Latin script generating code mixing. So what is code mixing? Code mixing refers to the coupling of 2 or more languages in a single sentence. It is a quite common phenomenon observed in multilingual societies throughout the world. It is widely considered as a default mode of communication in the current era. Okay, next, the dataset description. We got the dataset Tamil English code mix text derived from the social media platforms from a Coda Lab shared task competition. So I referred the paper here after the dataset name. So the training dataset consists of more than 35,000 comments of host in 6 different classes as shown in the slide. So first 3 is in one slide and other 3 is next slide. Okay, so if you take each and every one, not offensive means comments which are not offensive, impolite, or rude. That's category and the not offensive. So I put an example for each and every one. You can see it here. Other one is offensive, targeted, insult individual. So this comments targeting an individual. So we categorize those example into this category. After that, untargeted. Untargeted means the comments targeted no one. So those comments comes under this category. After that, offensive, targeted, insult group. So these comments are targeting the group as same as the targeted insult other category is refers to offensive comments targeting an issue or an organization or an event other than the previous 2 categories, means the insult an individual or the group. Other than these categories, come to the insult others class. Last one is not Tamil. Comments are not in Tamil, that is in native Tamil. Okay. So this diagram shows the class distribution in the training data set, training, development and testing data set that we have used. We can see that the imbalance of the data set depicts the realistic picture observed on the social media platforms. So we use this data set for our work. Okay. The automatic detection of such malevolent comment of post has become a crucial field of research in natural language processing in recent years. So we stimulate the research under this under-researched language. That's why we take Tamil as our language. So we intend to stimulate the research in under-researched language Tamil using bidirectional approaches and fine-tuning strategies. Okay. Methodology. We proposed a novel and flexible approach of CNN transformer networks like MBERT, DistilBERT, and UML-FIT to reap better results from fine-tuning and ensembling. So you can see the flow of work data set. We got the data set. After that, we did pre-processing. Then we fed the pre-processed text into the 4 different models. You can see the model diagram in the next following slides. So if you take the pre-processing steps, we have did some pre-processing steps for the data set. So lowercase the Romanized words. This is the most important because our models can take the input. If we take an example, bird, somebody use bird as first letter as a capital WORD, then other one used bird, all the letters are in small. So our model can't detect those words are same or different. So we have to change all the cases into lower. This can improve our model's performance. So this step is not performed for words written in Tamil script, as there is no such casing used in Tamil script. So that's why we can't expect the lower casing for the Tamil script. We use only for the English words. Okay, as well as we remove the emojis and emoticons from the text because as they generally do not carry any semantic meaning into offensive language identification. But if you can take the sentiment analysis or emotional analysis, the emojis and emoticons involved in the major role in those tasks. So in here we don't need that. So that's why we remove it. As well as we remove the URLs and the user mentions as usernames, phone numbers, email as well as pre-processing techniques. So if we go to our first model, CNN plus bi-LSTM. This is a hybrid of bidirectional LSTM and CNN architecture. The convolutional neural network, as known as CNN, extract the character futures from each word, or extract the future vectors from character level futures. For each word, these vectors are concatenated and fed into the bi-LSTM network. I mean, bi-LSTM means the bidirectional LSTM network, and then to the output layers. We use the softmax layer as an output here with the 6 different classes. CNN bi-LSTM along with the doc2vec embedding achieved very high results for sequence classification tasks. In one of the previous works we have read. So that's why we used globe embedding along with the CNN bi-LSTM to do a different work other than the previous work. So according to the corpus analysis we have did, we identified the data set. They used mostly Tamil script than language in our data set. That's why we used we have selected 2 embedding models. One is Glow and the other one is Wikipedia Tamil pre-trained model. So in here, CNN bi-LSTM, we used Glow embedding. We have used other embedding in our next model. I will show it. In BERT, multilingual models of BERT are largely based on the architecture of BERT. So this model was also pre-trained using the same pre-training strategy that was employed to the BERT. It was pre-trained on the Wikipedia DOM of top 104 languages. The pre-trained BERT multilingual model we have used BERT-based multilingual uncast. You can see in the slide, I bold it, BERT-based multilingual uncast. This is our pre-trained model that we have used. During the fine-tuning of the model, bidirectional LSTM layers were integrated into the model. So we have earlier, we didn't integrate the model into the, okay. I'll do it quickly. So bi-LSTM layer, from the transformer encoder, the bi-LSTM layer can take the embeddings at the input, which leads into the increase in the information being fed, which results the improvement of the context and the precision. As you can see in slide, I will show it. Here we did the research in with only the embed BS embed plus bi-LSTM. So we can see the improvement. First, with only embed we got 0.611, but if it integrate the LSTM layer with embed, then we can see the improvement. We got 0.7341. So it increases the performance in the weight F1 score. So next model is ULM-FIT. ULM-FIT is the effectively presented the method to fine-tune neural network for inductive transfer learning for performing NLP tasks. Language models are trained to adapt to various features of the target task. After pre-processing the text, a pre-trained language model as shown in the slide, AWD LSTM is fed to the data, then fine-tuned by adhering to the landed triangular learning rates by freezing some of the few layers, and dropouts were also we have applied. In here, we used FastRay as embedding to this experiment. You can see the results derived from this model. In here, ULM-FIT, we got 0.7414. This is better results. We can try up a better results from this model because I think in here we have used the Wikipedia pre-trained model. WikiTalm, you can see in the bottom of the line, WikiTaml 8K. So that's why this is particular. This is specialized for only the Tamil language. That's why we can reap better results from the ULM-FIT model as rather than embed plus bi-LSTM, because 0.7341, but in here we got 0.7414. So this is better results. Okay. In conclusion, I'll finish it quickly. In this work, we have explored various transformer models for detecting offensive language in social media posts in Tamil. We observed the class imbalance problem in the provided data set of the task. which has a consequently impact on system performance, I think. Okay, different network architecture can shows the different results in our work. Okay, our work manifests the fine-tuning transformer model results in better performance. The relatively high F1 score of 0.714 was achieved by ULM fit, and 0.7341 was achieved by the BERT bilateral model, as shown in the previous slides. For our future work, we intend to explore different transformer learning strategies and embeddings for better performance of our models. That's our work.
Thank you very much, Charangan Vasantharajan. An interesting presentation, very relevant. A lot of research done in English, and you're doing it in Tamil. And I can see the depth of your research. We need to congratulate you on your work. So we'll have the question and answer sessions later on because we are running short of time. And before I introduce the next speakers, Charangan Vasantharajan is a third-year undergraduate from the Department of Computer Science and Engineering at University of Maratua. And he's interested in natural language processing, computer vision, and artificial intelligence. And he's looking for an internship in the above fields as a research assistant. So if anybody is here from the United States or Canada or somewhere else, he'll be graduating soon, I suppose. So please take a look at it. His presentation is of extremely high quality. Thank you, Charangan. And he did his research under the supervision of